Science, Chemistry Chapter 2, Is Matter Around Us Pure? Have you ever noticed the word pure written on many products around us? Pure water, pure honey, pure milk. But are these substances really pure according to science? Let's enter the fascinating world of chemistry and discover whether matter around us is truly pure. Imagine a box containing only one kind of particle. Every particle looks exactly the same. When a substance contains only one type of particle, it is called a pure substance. Scientists consider a substance pure only when all its particles are identical. Examples include pure gold, distilled water, and oxygen gas. Now imagine a container containing two or more different types of particles. The particles are mixed together, but they are not chemically combined. Such a combination is called a mixture. Most things around us are mixtures. Milk, soil, air, and seawater are all examples of mixtures. There are two main types of mixture, first homogeneous mixture and second heterogeneous mixture. Let's understand them. Suppose we add salt to water and stir it well. Can you see the salt now? No, the salt has mixed completely with the water. Every part of the solution looks exactly the same. Such mixtures are called homogeneous mixture, homogeneous mixtures. A homogeneous mixture has a uniform composition throughout. Examples of homogeneous mixture are salt water, sugar solution, and air. Now look at this mixture. Oil and water are placed together. Can you see different layers? Yes, the composition is not the same everywhere. Such mixtures are called heterogeneous mixture. In a heterogeneous mixture, different substances can be seen separately. Examples of heterogeneous mixture are oil plus water, sand plus water, and soil. Let's make a simple solution. We take a glass of water. Now we add sugar and stir it. After some time, the sugar disappears. Has it vanished? No. The sugar particles are still present, but they have mixed uniformly with the water. This type of homogeneous mixture is called a solution. The substance that gets dissolved is called the solute. In this example, sugar is the solute. And previously, salt and water was also a solute. The substance that dissolves the solute is called the solvent. In our example, water dissolves sugar. Therefore, water is the solvent. When a solute dissolves in a solvent, a solution is formed. Sugar plus water gives a sugar solution. Salt plus water gives a salt solution. Not all solutions contain the same amount of solute. Look at these two glasses. The first glass contains only a small amount of sugar. The second glass contains much more sugar. The first solution is called dilute. The second solution is called concentrated. The amount of solute present in a solution is called its concentration. But have you ever thought about what actually gives a solution its unique properties? Why do some mixtures stay crystal clear forever, while others settle down over time or play tricks with light? Now we will uncover the key properties of solutions, explore suspensions and colloids, and witness the fascinating Tyndall effect. Now that we know what a solution is, let's understand its properties. A solution appears completely uniform. The particles of the solute are extremely small. They cannot be seen with naked eyes. The particles do not settle down even if the solution is left undisturbed for a long time. They also pass through filter paper. Because of these properties, solutions appear transparent. Now let's compare a solution with another mixture. Suppose we mix mud into water. At first it looks mixed. But if we leave it undisturbed for some time, something interesting happens. The mud particles slowly settle at the bottom. This type of mixture is called a suspension. Suspensions have several unique properties. The particles are large enough to be seen. The particles settle down after some time. Suspensions are not stable. Their particles can be separated by filtration. This makes them very different from solutions. Let me show you how filtration works. When muddy water is poured through filter paper, the mud particles remain behind. Only clean water passes through. This proves that suspension particles are large enough to be trapped by the filter paper. Now let's look at a special type of mixture. Milk appears uniform like a solution. However, it is not a true solution. The particles are larger than solution particles but smaller than suspension particles. Such mixtures are called colloids. The particles of a colloid are too small to be seen individually. Unlike suspension particles, they do not settle down. Colloids are quite stable. Their particles cannot be separated by ordinary filtration. Because of these properties, colloids occupy a special position between solutions and suspensions. Many substances around us are colloids. Milk is a colloid. Fog is a colloid. Smoke is a colloid. Whipped cream is also a colloid. Colloids are very common in daily life. Let's perform a simple experiment. A beam of light is passed through a glass of milk. Notice what happens. The path of light becomes visible. Why? Because colloidal particles scatter light in different directions. This phenomenon is called the Tyndall effect. Let's compare a solution and a colloid. When light passes through salt water, the beam is not visible. But when light passes through milk, the beam becomes visible. This is because colloidal particles scatter light while solution particles do not. Let's summarize everything we have learned. Solutions contain extremely small particles. Suspensions contain large particles. Colloids have particles of intermediate size. Solutions and colloids do not settle down. Suspensions settle down after some time. Suspensions can be separated by filtration, while solutions cannot. Now we understand the difference between solutions, suspensions and colloids. But how to separate different substances from mixtures? Scientists use different separation techniques depending on the properties of the substances present. Let's explore these fascinating methods. Suppose we want to obtain salt from seawater. Can we filter it? No, because salt is completely dissolved. Instead, we heat the water. The water changes into vapor and escapes. The salt remains behind. This process is called evaporation. Sometimes particles are too small to settle naturally. In such cases, the mixture is rotated at very high speed. The heavier particles move outward and separate. This method is called centrifugation. Centrifugation is commonly used to separate cream from milk. Oil and water do not mix. Oil is lighter and floats above water. A separating funnel allows us to separate these two liquids. The heavier water is removed first. The oil remains above. Some solids change directly into vapor when heated. This process is called sublimation. Suppose camphor is mixed with sand. When heated, camphor changes directly into vapor. The sand remains behind. The vapor can then be cooled and collected. At first glance, black ink appears to be a single color. But is it really? When the ink travels through special paper, different colors separate. This method is called chromatography. Chromatography is used to separate colors present in dyes and inks. Suppose we want pure water from salt water. Evaporation can remove water, but the water is lost. Distillation solves this problem. The mixture is heated. Water changes into vapor. The vapor is cooled and converted back into liquid. Pure water is collected. Sometimes two liquids are mixed together. If they have different boiling points, they can be separated by fractional distillation. Crude oil contains many useful substances. Fractional distillation separates petrol, diesel, kerosene and other fuels. Some solids may decompose during evaporation. In such cases, crystallization is used. A concentrated solution is prepared. It is allowed to cool slowly. Beautiful pure crystals are formed. This method is commonly used to purify solids. Let's quickly revise. Evaporation separates dissolved solids. Centrifugation separates particles using spinning. Separating funnels separate immiscible liquids. Sublimation separates substances that convert directly into vapor. Chromatography separates colors. Distillation gives pure liquids. Fractional distillation separates liquids with different boiling points. Crystallization produces pure crystals. So far we have learned how different mixtures can be separated. But what exactly are pure substances made of? Earlier, we learned that a pure substance contains only one type of particle. Scientists classify pure substances into two major categories: elements and compounds. Let's understand them one by one. Imagine a substance made entirely of one kind of atom. Every particle is exactly the same. Such a substance is called an element. An element cannot be broken into simpler substances by chemical methods. Gold, oxygen and iron are examples of elements. There are three main types of chemical elements: metals, nonmetals, and metalloids, grouped across 118 total individual elements in the periodic table. Many elements are metals. Metals are generally shiny. They conduct heat and electricity. They can be hammered into sheets and drawn into wires. Iron, copper, aluminium and gold are common metals. Some elements are nonmetals. Most nonmetals are poor conductors of heat and electricity. They are generally not shiny. Oxygen, sulfur and carbon are examples. Certain elements show properties of both metals and nonmetals. These are called metalloids. Silicon and germanium are common examples. Metalloids are very important in electronics and computers. When two or more elements combine chemically in a fixed proportion, a compound is formed. Water is a compound made from hydrogen and oxygen. Common salt is a compound made from sodium and chlorine. The properties of a compound are completely different from the elements that form it. Let's compare them. An element contains only one type of atom. A compound contains two or more elements chemically combined. Elements cannot be broken into simpler substances chemically. Compounds can be broken into their constituent elements by chemical reactions. Matter can undergo different kinds of changes. Some changes affect only the appearance or state of a substance. These are called physical changes. No new substance is formed. Melting of ice, boiling of water, cutting paper, dissolving sugar in water. All these are physical changes because no new substance is produced. Some changes produce entirely new substances. These are called chemical changes. The original substance is transformed into something new. Burning paper is a chemical change. Rusting of iron is a chemical change. Cooking food is also a chemical change. In all these cases, new substances are formed. Let's compare physical and chemical changes. Physical changes do not form new substances. Chemical changes produce new substances. Physical changes are often reversible. Chemical changes are usually irreversible. Before we conclude, let's look at a few interesting facts. Air is a homogeneous mixture of gases, while soda water is a solution of carbon dioxide dissolved in water. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal, made to improve strength and durability. Surprisingly, diamond and graphite are both made of carbon, yet they have completely different properties due to the different arrangement of their atoms. Let's revise everything we learned. Matter may be pure substances or mixtures. Mixtures can be homogeneous or heterogeneous. Solutions contain solutes and solvents. Suspensions and colloids have unique properties. Scientists use separation techniques to obtain pure substances. Pure substances are classified as elements and compounds. Matter can undergo physical and chemical changes. Chemistry helps us understand the hidden world around us.